Okay, friends, welcome to my YouTube channel. I'm Prof Prism, and in this series of videos I'll be doing, or lessons I'll be doing, I'll be directing it specifically to my friends preparing for their BCE exams. And I expect that as many of them as possible should subscribe to the channel, as I'll be highlighting some important portions of their exams they would have to pay more attention to. So right from today, the first thing we'll be looking at is rigid motion. When you realize that most questions or majority of the papers over the years have rigid motions somewhere in them. So it's important we look at it, and we'll be starting from what rigid motions are. When we say motions, we are just looking at movements. Motion simply means the movement of an object from one point to another. So what then is rigid motion? Rigid motion, so mathematics, and we are looking at rigid motions. So rigid motions they are also called isometry or congruence transformation. Isometry or congruence transformation. Congruence transformation. Okay, so when we say rigid motions, we are looking at the motion of a body rigid motion is defined this is the movement of an object or a figure from one point to another without from one point to another without a change in size and shape. So these two words, let me underline some important words that stand out in this definition. The figure, and then the fact that there is no without a change in size and shape. Without a change in size and shape. There are other form of motions that would mean that there will be a change in size and shape, like dilations and enlargements. However, for rigid motions, we are looking at that kind of transformation or that kind of movement where there is no change in size and then in the shape. That's basically what it is. So let's take a look at the main words that I just mentioned. The figure. So we look at the figure, and then all this statement here refers to the fact that it is congruent. So when you hear this word congruence, it simply relates to the fact that it simply relates to the fact that there is no change in the size and then the shape, simply. So the figure would be in two forms. We have what we call the pre-image, also called the original figure. So the pre-image, so the figure is in two parts. The figure is in the pre-image, also called the original figure. Or it could also be referred to as the object. And then the post image, also refers to as just the image. And like I said, when you look at congruence, and like I said, when we look at congruence, we are relating to that attribute of this motion that is without a change in the size and then shape. We have three main types of rigid motions. We have reflections, we have rotations, and then we have translations, reflections, rotations, and translations. These simply are everyday occurrences. Reflection, when you've ever stood in front of a mirror, you see an image flip. So a flip over, that is a reflection. There's a flip over. That is a reflection. And then when there is a turn, so flip over, see another image in front of you. Like you see in a mirror, or like you see when you just look into a water body, you see another image right there. So that's what we call the reflection. And then we also see a rotation, that's a turn over. Then we have translation, that's a slide. So when I move from here to here, that is a translation. When I turn, a rotation. And I don't know how I'm going to flip over. Probably should go and stand in front of a mirror. Or I'll bring a mirror to the next lesson. So that's a flip, that's a reflection. So reflection, rotation, translations. Now let's start with what a reflection is. Reflection, this is the movement of an object about a line of reflection. This line of reflection is also called a mirror line. Okay, so we have this. Let's take this as our mirror line, as our mirror. And we have an object here, right in front of the mirror like this. When this object flips over, we would have something like this. So this becomes our pre-image, and this is our mirror line. And then, okay, sorry. Just in case, help the color. So our mirror line, also called a line of reflection, and this becomes our post. So pre-image, mirror line, and then our post image. Usually when you are seeing it in any maths, they will do attributes. Let's see an A to the coordinates of the pre-image, and then you see an A prime attributed to the coordinates of the post image, and it goes in that order. So if this also reflects again, we would have that as A double prime. So those are very basic things you'd have to note about reflection. One last thing is that you should know that the distance from the object to the mirror is the same distance from the image also to the mirror, or the line of reflection. So the same distance from here to here is the same distance here. I've not drawn mine to scale, so you wouldn't reflect, you wouldn't see it very clearly. But if you should use a graph book, you always have to know that the distance you have from the object to the mirror line should be the same distance from the image also to the mirror line. Very important. Okay, now next thing to look at after reflection is to look at rotations. Okay, in talking about rotations, we would have to look at two important things. Rotations would mean the movement of an object, about an origin. or about a certain point. So the movement of an object above a certain point in a certain direction. So let's just look at the various elements we'd have to look at in the definition I just gave. We'll need the center. We look at the center, we look at the directions, and then we look at the angles. Directions, and then we look at the angles. These three elements are very key when it comes to rotations. So the center, it could be about any point. The directions are 2. Let me bring my clock to illustrate this. So as you can see here, the directions are primarily seen in 2 ways with reference to a clock. The directions are seen in 2 ways with reference to a clock. As you can see here, they are with reference to a clock. As you can see here, this clock is moving in this direction. So we call this direction the clockwise direction. We call this direction, so as you can see this clock, it's moving normally like this. So this is what we call the clockwise direction. So this is clockwise. If the clock should move in another direction, it's called anti-clockwise. So I'm going to remove the battery to show you how. So this is its normal movement. So that's clockwise. It moves from 7 and it goes to 8. Now if it should be moving this way, this kind of an abnormal movement, you can see that it's moving from 10 to 1. It's moving backwards, or we call it anti-clockwise or counter-clockwise, basically. So those are the 2 directions. So the directions are clockwise and then anti-clockwise or counter. I'm repeating some of these words because sometimes some students can get used to a word such that when the question is even changed slightly, they find it difficult being able to relate. So he knows anti-clockwise, and then he meets a question where he sees counterclockwise, and he's like, oh, we're not taught this in class, but it's the same thing. Okay, so the angles, we'll be looking at about 4 major angles. All right, so we'll look at 4 major angles. We'll look at angle, the beginning of the angles. We'll look at angle 90. We'll look at angle 180. We'll look at angle 360, base 270, and then still the beginning, which is going to be 360. So these two can either be, these angles could either be clockwise or it can also be anti-clockwise, basically. So let's see something like this. If we are given this as an object, at a certain given angle, maybe this. So I'm trying to move it. I'm trying to move this in a clockwise direction. So clockwise, I'll be expecting to have something like this. So this has moved in a clockwise direction about an angle. So this is the angle. So I have this as my angle. I have this as my pre-image. I have this as my post-image. I have this as my direction, which in this case is a clockwise direction. Or I could also, if I would flip it to this other side. So as when I move this guy back to this place, that would be an anti-clockwise. Or let's better still use a pre-image and have another image right here. We would have something like this. So this guy would come here, about 90 from an image like this. So pre-image about 90 anti-clockwise. So anti-clockwise. So pre-image, we have this as our image. Basically, that's what it is. Okay. So post-image, pre-image, and then image, all being rotated at various angles. So this is what we see as rotations. We will have a more detailed video where we see how we can plot the various coordinates, and it's going to be interesting. Now, third one is translation. And under translations, we are looking at the movement of an object or figure in about a distance in a direction. And this direction should be the same as the direction of the object. The direction of the image should be the same as the direction of the pre-image. So we have something like this. Watch this. So we have our y and then our x coordinates like this. And then we have an object here. So we could move this object, so plus minus y minus x, and then plus x. We could move this object this way and bring it down like this. So we have slided it this way and then brought it down. So we have an image here. Just trying to draw something not to scale. So we have this to this. One thing you can notice is that if it's a translation, this object here would have the same direction as the image. So you don't expect to see an image facing this direction. If that's the case, that is no translation. So we'd have to look. So first we must notice that the image, so number one, the image, the object and the image will face the same direction. So number two, we would have about translation to the right, translation to the left. We would have translation to the right, so this way, translation to the right, and it's going to be positive. Translation at this direction is going to be, so translation to the left going to be negative because this is a negative axis, and translation downwards negative. So an object can either move downwards, and if it's moving downwards, it's going to be affected negatively. When it's moving upwards, so translation downwards and then translation upwards. Okay, so these are basically a summary of the various forms of rigid motions. This is a summary of the various forms of rigid motion, the definition, the reflection, rotations, and translation. So this is a summary. In the subsequent videos, we'll be tackling each and every one of them one by one and how to find their coordinates. You would want to subscribe to this channel and like this channel, and also press the notification bell so that when the other videos are ready, you quickly watch them, and then I believe that it's going to be a great time. Bye bye.